last time we were discussing the basics of integration, and unfortunately, I think the lecture got a little bit cut short because of whatever reasons. But so we will require one more lecture today to complete integration. Okay. Meanwhile, I think people have also attended the kinematics 1 lecture for the board lecture series. Okay. So when we finish calculus, we'll be actually moving on to kinematics in this track also, which is for your JEE exam, JEE and NEET. But in that, like when we come to kinematics 1, we'll discuss things in a lot more detail compared to what we've done in the board lecture. The board lecture was just the basic definitions and some formulae, which is what is required for your board level preparation. Okay. So anyhow, let's get underway. So today will also be calculus. We will complete integration.
So after integration?
After integration, we finish calculus and we come to the next section, which will be kinematics in this track.
Okay, sir. So kinematics will also, like calculus will also be there in kinematics?
Yes, calculus application will be there as well as vector application.
Okay.
Both the things to a certain extent. Not all the things. For example, there will be very little of chain rule application in kinematics, more like basic differentiation, integration, those kind of things.
Okay, sir.
Similarly, there will be a little bit of component algebra from vectors which will be applied in kinematics. But for example, there won't be dot product, cross product, those kind of things. They will come in later chapters again. Right. So let's start with a quick recap of indefinite integration that we had learned. We've seen that the operation of indefinite integration given by this kind of symbol. So indefinite integration of a function fx with respect to the variable x gives us what is called the antiderivative of the function. So this is called, what we get as the output of the operation is the antiderivative of the function fx. So that means that if we were to differentiate this function, if we were to find the derivative of ix, that would give us fx. Okay. So basically the idea is that the two functions are related to each other in such a way that we can convert ix from fx by integrating this. So that means we can again convert ix into fx by differentiating. So they are reverse operations of each other. That's why it is called antiderivative. So having understood this basic definition, we had then seen the basic formulae of indefinite integration. So today we will first of all complete that list of formulae. So seeing that integration of x to the power n is generally speaking given by this formula, except for the case when n is equal to -1. So this is valid for all real numbers n except n equal to -1. That's an important exception. So for the exception n equal to -1, the formula is ln x plus c. Okay. This is the exception case.
Sir, what is that symbol called, which is a big F type?
Sorry?
Sir, the big F, what is that symbol called?
This symbol is called the integration symbol. Okay.
Okay,
And sir, what is that C called in that formula 7?
And the C, as you know, is called the constant of integration. Okay, so
Okay.
this whole thing will be read as integration of the function fx with respect to the variable x, because this dx stands for the fact that we are integrating it with respect to x. Just like when we write differentiation like this, it means that we are differentiating with respect to x. So the dx in the denominator tells us that we are differentiating with respect to x. So like that in the integration, when we have the symbol of integration, some function and then this dx over here. So this dx tells us that we are integrating with respect to x. Okay. And over here, when we get the antiderivative, the value of c, it's an indefinite value because it can be any real number. So that is called the constant of integration. C is the constant of integration. C can be any real number. So that is why it is called indefinite integration, because output is not a definite value. It is a function which has an indefinite term in it, which is the indefinite constant. So these were the like two basic formulae to start with. Then we had also seen about sine and cos. Okay. So I'm just giving you a minute to go through this section. If there's any further doubt in it, please let me know. We'll discuss. Okay. You have this in your notes, so you did not write down again. Yes, Tejas, what you are saying is correct, that if we were to integrate the double derivative of a function, it would give us the derivative. Okay. But like that's a very like twisted type of operation, so we need not worry about something so complicated right now. But yes, you can see that, for example, what we are saying, suppose we have a function x2. So the derivative of this function, the first derivative is 3x square, the second derivative is 6x. Okay. Now if we were to integrate the second derivative, according to our concept, what we should get this, and you'll see we'll get this. Okay. This will be 6 comes outside. So 6 into now integration of x to the power 1 will be x to the power 1 plus 1 upon 1 plus 1 plus c, by that formula, that x to the power n formula that we'd seen. So as you can see, you're getting here 3x square plus. So if I've taken any function, differentiated it twice, and then integrated that second derivative, it should give me the derivative. So any function's second derivative, this was your question, what happens if we integrate this? You should get the derivative of that function. Okay. But there will also be this constant term, which was not there in the derivative. Okay. So that's where the indefinite thing comes in. Right? It gives us an indefinite answer. So anyway, I hope this answers your question. So Tejas, I hope that point is clear. You can just, in case you're not able to answer me audio-wise, you can just send me a text message with answer. Okay, good, very good. Okay, now let's look at some more formulae. Now we had seen the two basic trigonometric ones in formulae. So along with these two formulae, we had also seen that integration of sine x is given by minus cos x, because differentiation of cos x is minus sine x. So integration of sine x becomes minus cos x. And we had seen integration of cos x is sine x. Now today we'll see the rest of the 4 trigonometric ones also. So for integration of trigonometric functions, the basic ones, let's complete our list of formulae.
So we have completed that.
You've done that also, tan x and all we have seen last time?
Sir, we have done till
Okay,
definite
sir.
integration.
Okay. Okay. No, I don't know we have done till to definite integration. I just didn't remember that we have done these formulae or not.
Yes,
Yes,
sir.
we have
we
seen
did
all
that.
these formulae. Right?
Sir, we have
Yes,
done.
sir.
Okay. Okay. So these are the formulae that you have to remember always. Okay. Cot x. So this is ln cosec x plus cot x with a minus sign. Okay. This is ln sec x plus tan x. This is ln sin x, or we can also write it as ln minus of cosec x plus c. And then we must have seen the final one, the exponential. So the integration of e raised power x is equal to e raised power x itself. So this is our list of formulae. Along with this, we have seen the properties of integration also.
Can you scroll a bit up? I just wanted to know the last one.
Yeah, I'll go through it. Okay. So the properties, just a minute. The first property is that integration of a constant is a linear function. Okay. Then second property is that if we have a constant into a function which we are integrating, we can take the constant outside and integrate the function. And the third property is that the distributive property kind of thing, that the integration of the sum of two functions becomes the sum of their individual integrations. or for that matter, if there's a difference of two functions, then we can take the difference of their individual integration. So if the sign in between here is minus, there will be a minus sign. Okay. So with these properties along with the formulae, I'll take you back to that part also. You can integrate virtually any basic type of function. Now today we'll also see that if there's a slightly more complicated type of function we are integrating, then how to use something called integration by substitution, like we had learned chain rule in differentiation. Like that. Yeah, which part you wanted to check again?
Formulas. Last
Okay.
that one.
The formula section starts from here, and there's the exponential one below this.
Yes, sir, done.
Okay. So let's do a quick example exercise of some integrations. We'll discuss some definite integrations also in just a bit. Okay, just work out these three integrations and send me the answers on the text message if possible.
Sir, sir,
Harsh, your answer is correct for the first one. Vedant, you have to just check one of the algebraic signs. Okay. Just go through the formula once more if you like. Now, one thing you can always do in like, especially integration like the first one. Yeah, correct, Avi. You can always check your answer by differentiating it once. Tejas, I'm checking your answer. The first one is correct. Let me just check the second one. Yeah, second one is also correct. Manya correct. Vansh correct. Once the third one is not correct, beta, you have to check the answer. Okay, people, most of you have got one or two correct, but the third one, unfortunately. So anyway, let me work out the question part by part. So the first one, integration of sin x minus cos x. If you go by a step-by-step method, what you should do is you should first separate out the two functions. The minus sign in between them, so the minus sign comes outside. Then use the formula. So you know that integration of sin x is minus cos x by definition. Okay, and you can say it's got one constant. Integration of cos x is sin x, and there's another constant. But what you can do is the sum of these constants is a constant, which is indefinite. So you can just write it as a constant. Or what you can do is you can write it as C1 and C2. Okay, and just combine them as a single constant later. So you can take this one as C1, this one as C2. And just combine the two constants and write it as C, as a single indefinite constant. Okay. So your final answer should become minus of whatever order you write, it doesn't matter, minus cos x minus sin x. So this is your antiderivative of this. And you can just verify it by differentiating this, you will see you'll get sin x minus cos x. Now second one, a little bit more complicated because you have to simplify this expression first before you can do anything else. So what you can do is you can write this as x squared by root x minus 2x by root x first, okay, and then simplify it as x to the power 3 by 2 minus 2 times x to the power half. Then sub dx here. So it is just like, systematic application of the properties and all that, nothing more than that. So now you apply the x to the power n formula. The integration of x to the power n is this. Let's apply that. So become, again, I've written the single combined constant instead of C1, C2. So this will become 2 by 5 x to the power 5 by 2, okay, minus 4 by 3 x to the power 3 by 2 plus. So the answer is okay as far as this is concerned. You can leave the answer this way, or you can just simplify it a little more if you like. So you can take, for example, x to the power 3 by 2 by 3 common. In fact, this. So you will have x minus 2 plus 3. Or you can write it as, but this is all basically just expressing it in a different way. The answer is correct as far as this is concerned. This only is the correct answer. They're just
So
different.
why did
ways
you
of
take 3 as common? Because there's 5 in the
Oh,
denominator.
sorry, my mistake. My mistake. Yeah, you can't take 3 common. So take, this will be by 5, right? Minus 2 by 3. Is it correct now?
Yes.
Yes, sir.
Okay, so that's the second one. Okay. And then I'll come to the third one. Just required make a note of this. The third one, just in case some of you are solving it right now, take note of the fact that the second integral you get will be the exception case of n to the power minus, I mean, the power n will be minus 1. So be careful when you're simplifying it.
So, but you gave the question as x cubed plus x squared by x.
Oh, sorry. Then it's okay. Yeah. Then the second term will be x square by 2, which is correct. Okay, Vedant, your answer is correct. Others are also correct. Avi, your answer is also correct. Yeah, Rushi, your answer is also correct. Vedant, your answer is correct. Tejas correct. Bunch correct. Okay, good. Yeah, so that makes this integral very simple actually, isn't it? So I think all of you would have got this by now. Okay, now next thing we'll do is, of course, we'll come back to definite integration also in a bit of time, but we will see something called integration by substitution as part of indefinite integration.
Sir,
Yes.
sir, can you scroll up for a second?
Yeah. Which question? The second or third or?
Sir, third one.
Oh,
Okay, sir, thank you.
oh. Yeah. So now we come to another technique that is used for integration, that is indefinite integration. And this is integration by substitution. So you can say it is somewhat similar to the process we used to do in application of chain rule in differentiation. The idea is a little bit similar to that. So the first type of substitution we will see is that when a linear term is substituted. So I'll just express this with an example first, and then we will see the general method. So suppose we have something like this: square root of 2x plus 1. I want to find its antiderivative. Okay. Now I know that antiderivative of root x is what? It is 2 by 3 x to the power 3 by 2 plus c by formula. Okay. But because inside the square root I have this 2x plus 1 term, now I have to do something to use this formula directly. I cannot use it directly over here. I have to modify this in some way so that I can make use of this formula. Right. So what we do is, inside the square root we have a linear term 2x plus 1. Okay. Notice that this is a linear term. So this 2x plus 1 is substituted as a dummy variable. So we introduce a dummy variable like we used to do in chain rule. That's why it's a similar thing. So we substitute 2x plus 1 as any variable we like. So let's say I'm taking the name z. So that's my dummy. Now the moment z is this, that means what is dz by dx? It is differentiation of 2x plus 1, which is just 2. So this statement that dz by dx is 2 now implies that dz by 2 is equal to dx. I'm just cross multiplying. Okay. Dz by dx is equal to 2. I've just cross multiplied that. So now this term and this term, they will both be substituted in the integral. So my original integral, which was square root of 2x plus 1 into dx. In this, I will substitute 2x plus 1 as z. Okay. But having done that, I cannot leave dx this way because now the variable has become z. So I have to convert dx also in terms of dz. So this will also be substituted. This will also be substituted. So dx will be substituted in terms of dz as what? Dz by 2. And that 1 by 2 simply comes out. So I'm left with root z dz integration. Okay. So for that, now I can use the formula z to the power half plus 1 upon half plus 1, the standard formula that I had used earlier also. Okay, plus the constant of integration. So this becomes, as you can see, this becomes z to the power 3 by 2 divided by 3. This half and 2 will cancel plus c. And now I have to resubstitute. We have to resubstitute the dummy z as 2x plus 1 because that is a variable we had introduced. So again, you see it's a little bit similar to the chain rule concept, like the steps were done. So this becomes 2x to the power 3 by 2, whole thing divided by 3 plus c. Okay. So this is the antiderivative for this integral. So this tells me that the integration of this quantity, square root of 2x plus 1, should give me this. Okay, and later we'll verify it by checking that it gives root 2x plus 1 when we differentiate it also. Okay, but this is the method. So just note down the heading and go through this example. Then we will generalize this method. What I've done for this particular example, we'll make a general method out of it. Okay. So this is the first type of substitution in the topic of integration by substitution. That is when we substitute a linear term. So here, for example, that linear term is 2x plus 1, and we have substituted it as the dummy variable, which I'm calling z. Of course, finally, the dummy variable is removed. Okay, so our answer should be again in terms of x. Okay, so just go through the steps carefully over here, and let me know if there's any doubt.
Sir,
Yes.
sir, except the chain rule method, the difference is only that we differentiate 2x plus 1 to get the dz by 2, no?
But we are using differentiation, that's a different thing. But what is similar to the chain rule is the substitution and resubstitution step. There
Yes,
is no
sir, just
chain rule.
the step in red is extra.
Right. That's why I said that it's, you can think of it like a similar process to what we did in chain rule. It's not the same thing because there we are differentiating, here we are integrating.
Okay, sir.
Okay.
So done.
Okay, so this particular example is clear, I hope, to all of you. Now we will make a general method out of this process of substitution of a linear term. So if we have integration of some function which is composite in nature, then it is f of ax plus b, not f of x. Okay, and we know that integration of fx is ix. Okay, then substitute the linear term as a dummy. Okay, so the derivative of z with respect to x becomes a. So you can cross multiply that now. Okay. We can see that dx is equal to dz by a. So our integration becomes integration of fz into dx, which is dz by a. So this comes out. So this becomes 1 by a iz. This contains the constant of integration. Okay, and now resubstitute. So this becomes 1 by a I of z, which was ax plus b. So the integration of this function f of ax plus b, this type of composite function, is now given by this formula, where I is the antiderivative of this. So you can use this also as a direct formula. While the process is this, these are the steps. This can also be used as a direct formula. So how we could have used this as a direct formula in the previous question? So we have integration of square root of 2x plus 1 dx. Now we know integration of root x is 2 by 3 x to the power 3 by 2 plus c. So here, when we apply this formula, integration of 2x plus 1 to the power half will become 2 by 3. Now replace x with 2x plus 1. Okay. But there should also be a term of 1 by a. So that is that 1 by 2 term. Yes. So this is basically 1 by a I of ax plus b. This is what we've done. Okay, so this integral then becomes 2x plus 1 to the power 3 by 2 by 3 plus. Okay. And this is what we got by the substitution steps method. So once we become familiar with the process and the steps and all that, then we can start using it as a direct formula also. Every time we don't need to apply the steps like we've done in the previous one. We can directly apply the formula like we've done on the side over here for this integral.
Sir, in case of one, if it would be 2, we would directly apply 2 upon 2.
Sorry, in the case of?
In place of 1, if it would be 2, then it would be 2 upon 2, right?
Yeah, exactly.
Okay, sir.
Done, sir.
Okay, so you've written this down, right? So let's do a couple of questions based on this.
Sir, if a is equals to 1, then the integration would be similar to the normal one, right?
Yeah. So for example, instead of this, if I had something like this, if I had square root of x plus 5 dx. Okay. So now this will become what? It will become x plus 5 to the power 3 by 2 divided by 3 by 2. Okay. Into 1 by 1 only, because that, but there's still a bit something extra. That plus 5 is there extra.
Yes, sir.
But yeah, the coefficient of x is 1, so there isn't extra term in the denominator. So still 2 by 3 is the coefficient, but this term instead of x to the power 3 by 2 is now x plus 5 to the power 3 by 2 plus. So this will become the integral. Understood, no?
Yes, sir.
Similarly, you could also have a situation where that constant term is not there, only ax is there, not b is 0. Okay, so all those possibilities are there. A and b are any constants here. You can just add that point that a and b are constants. They're not variables. So let's do an example question with some applications. So integration of e raised power 3x plus 5. Then integration of dx upon 5x plus 2. Integration of sine 2x. Okay, just try out these 4 questions, should not take too much time. You can use the direct formula method like above also, or you can go by the step-by-step method. It actually won't make too much difference.
Sir,
Yes, people. I'm just going through the answers that you have sent. Yeah. Yeah. Once the first one, there's one extra factor. Otherwise, everything is correct. They just correct for the first one. Second also. They just you have sent me only two answers, right? Okay.
Sir, I have sent right now 3.
Okay. Okay. Acha, okay. Right. C is also correct. Okay. Alright, so I'm putting up the answers first. Okay, just go through them then. So this one should give you 1 by 3 e raised power 3x plus 5 plus c. This should give you 1 by 5 ln of 5x plus 2 plus c. This should give you minus cos 2x into half. And this should give you c was what? 1 by root 3 into 2. So 2 by root 3, the last one. Or you can also write it this way. So the last one you would have realized you actually don't need to do any substitution and all. You can just take the 1 by root 3 outside. Okay, so anyway, if you want to go with the step-by-step method, in the first one, substitute 3x plus 5 as z. So dx will get substituted as dz by 3. So the integral will become e raised power z dz by 3. So this is the step-by-step process. So as I told you that even if you go with the full steps, it's not that lengthy. So like that, in this you would substitute 5x plus 2 as a dummy variable. In this you would substitute 2x as the dummy variable. In this you need not substitute actually, but you can. The last one, it will be totally unnecessary to do substitution. You can just do this.
So,
Yes.
so we could also do these by direct formulas, right?
Yeah, like the first set of answers that I've written, I have done the calculation directly using the formula.
So can you show the second one by the direct formula method?
Yeah, see, the second one is like this, that you know that integration of dx by x is ln x plus c. So integration of dx upon any linear function ax plus b will become what? The antiderivative ln, but of that linear function, the whole thing divided by a plus c. Now just put a as 5 and b as 2 or whatever. Whatever.
Oh, okay. Understood, sir.
Okay, so people, all these questions are clear, I hope.
Yes.
Anyone?
Could you just explain the last one?
The last one. Okay, so last one, as I said, that actually we don't need to do anything extra in this. We can just take the root 3 outside. No? So the simplest way of doing this question, which is what should actually first of all strike you, that you can write this as this. No? You can just take the 1 by root 3 outside. You understanding? No?
Yes, sir.
So this is the most direct way of doing the question. Okay, so x to the power minus half plus 1 upon minus half.
Sum number 4 it is.
Yeah, this is the last question.
Okay, sir.
The last one. Okay. So this is ideally how you should do it. Okay, but in case for whatever reason you decided to go for substitution, you can also do it this way, that substitute 3x as z. Okay. So dz by dx is 3. So that means I can substitute dx as dz by 3. So my integration will become, it will become 1 by root z, okay, into dx, which is dz by 3. So 1 by 3 dz by root z, or 1 by 3 z to the power minus half dz. Now I'll use the formula. Okay. So z to the power minus half plus 1 upon minus half plus 1 plus c. So a little bit more algebra involved now. So you'll see you get 2 by 3 z to the power half plus c. So that is 2 by 3 square root of z. Now z was what? 3x. So when you finally resolve this out, you can see that it is 2 into root 3 into root x divided by 3. So ultimately it's that only. It's 2 by root 3 to root x plus. So this is like a overly lengthy method of so actually just makes it more complicated than necessary. Yes.
Sir, can you solve third one?
Sorry, which one you want to?
Sir, third one.
Third one. Okay. Third one was the sine 2x one. No? So in this, what we
Yes,
do,
sir.
understand that, see, integration of sine x is what? It's minus cos x plus c. So integration of sine of any linear function by the formula will become what? Minus cos of that linear term. X को replace कर देंगे with ax plus b, but then we have to also divide by. Okay. So यहाँ पे in this one, just take your a as 2 and b as 0 now for that linear term. So it will become that only. No? ठीक है, it's clear now?
Yes.
So can you show the last sum, please? Means the fourth sum.
Yeah, we just did that.
Yes, sir. This one only, red one. Yes, sir. Done.
Okay. Now we come to a second type of integration by substitution. In this one, what we do is substitution of a function, let's say gx, within a composite function. So for an integration of this type, f of gx multiplied with another term which is derivative of gx, okay, where g prime x is the derivative of the function gx. What we do is we substitute the inside function in the composite function, that is gx, as a dummy variable. So the moment we do that, so then what happens is dz by dx becomes g prime x, derivative of this. Okay, so we can substitute g prime x into dx as dz, and the integration becomes integration of f of g. Now g we have already substituted as z into g prime x into dx, so that becomes dz. So that becomes antiderivative of this, and then we just resubstitute. So the integration of f of gx, whole thing multiplied with g prime x dx, simply becomes antiderivative applied to gx plus, I mean, that c is actually included in the antiderivative, so you don't need to write it separately. So this can be used as a direct formula once again, once we understand this with few examples. Okay. So this is the result that we get. Okay. So these are the steps that we apply. This is the direct formula that can be used. But for this to be applicable, the integration has to be of this type. It has to be some composite function multiplied by the derivative of the term inside the composite function. Both the things must be there. Then only we can apply this formula directly. So just make a note of this. This might seem a little odd right now, like without an actual example, but note down the steps in this method, and then we will see plenty of actual examples so it will become clear to you.
But there will also be a constant, right?
Okay, people. So let's apply this to an example question and understand this. Okay. Suppose, for example, we have something like this. Okay. So you can see over here that you are having the product of two functions, 1 upon square root of 1 plus x square into 2x, okay, dx, this thing. Now, if you think of this quantity as the inside function, then this quantity is its derivative. Okay. So it is basically of the type f of gx into g prime x into dx, where your gx is this term 1 plus x square and f of gx is basically 1 upon square root of gx. So that means we can apply this method. So what is the substitution we will use now to do this question? We will substitute gx as z. So this integral is of the type, this one, so of this type. So the substitution that we do is gx over here, which is 1 plus x square, is substituted as z. So dz by dx is 2x, it's differentiation of 1 plus x square. So that means 2x into dx. So when you cross multiply this, you can see that 2x into dx can be substituted as dz. So this thing and this thing will be put as substitutions in the integral. So with these substitutions, now my integral, which was 2x into dx in the numerator, divided by square root of 1 plus x square in the denominator. So the numerator, the whole thing 2x dx is becoming dz. And the denominator 1 plus x square is z. So it's becoming a very simple integral. So it is integration of z to the power minus half. So that is, and then resubstitute. So it is 2 times square root of z, which was 1 plus x square plus. So that has become my integration. So you can see that what we had discussed, that integration of f of gx into g prime x is nothing but I of gx. Okay. So integration of 2x dx. So here we saw that gx was 1 plus x square and f of gx is 1 by root gx. Okay. So I of gx should be 2 root gx. So that should become 2 times square root of gx. So it's a little difficult to go with a direct formula method. You need a lot of experience in doing integrations to be able to do this using the formula method. So better is you go by the step-by-step method like we discussed. So just go through this example, make sure you understand each of the steps. Tell me if there's any doubt.
Sir,
Yes.
sir, actually, sir, I have a doubt. Sir,
Yeah, tell me.
after, sir, I'm just asking that, sir, in board lecture and in normal lectures, sir, kinematics will be different or same only?
normal lecture, the IIT lecture kinematics will be much more detailed. Like what is
Okay, and
there
the
in the
board
board lecture will also be covered, but lot more than that will be there. Okay.
Okay, sir,
A
understood.
lot more conceptual, and then IIT level questions also will be starting. Okay?
Sir,
Okay,
when
sir.
will we get the second module? Because now the major test 3 is coming, means it's very near, it's August 3, and we didn't get the module 2.
Okay, kinematics is there in module 1. Newton's laws wala
Okay, yes,
module
yes.
you haven't got the PDF. Haven't you got Newton's laws module? The second one, sir is not sent.
No, sir, I'm asking about the hard copy, I'm saying.
Hard copy. Acha, hard copy will take some time better because the printers have
And
not
neither
released
the
the
soft
pattern.
copy is sent.
Yes, sir.
Yeah, as of now, only the soft copy is there. Probably like in another day or two, it should be available. Let's see. Okay.
Okay, sir.
Sir, one more
Because
thing, we should attend board lecture and this IIT lecture also, right? Both of them.
sorry, what?
Sir, we should attend the IIT lecture
Yeah,
and
yeah,
this both of them,
both.
no?
Yeah, you should attend. Like whichever board you are in, doesn't matter. ISC, CBSC, or HSC, you should definitely attend the board lecture. Like for HSC, the college has not started yet. The admission only has not happened, but still you should attend the board lecture because otherwise, when the college term starts, there'll be too much of like backlog accumulated. Okay.
Yes, sir. Thank you.
Yeah. Okay, people. So hope this example is clear to all of you. So let's work out some more examples of this kind of application. We try out these 3 questions we will discuss. Actually, we'll do one more. We'll see that this integration that we've seen earlier, this is ln sec x. Okay. Show by using substitution. Okay. By expressing tan x as sin x upon cos x. Okay. And then solving this by using substitution.
Done.
Okay, people, let's check out the answers. It's very good. The answer of the first one is sine cube x by 3 plus c. Arushi, that's correct. Second one will become e raised power x square by 2 plus c. Third one will become yeah. So minus ln cos x, Vedant, is ln sec x only. You just take the minus sign inside the ln, so it becomes a power. No? So you use this property of ln, that ln of x to the power n is n ln x. So like that, you can say that minus of ln x is ln of x to the power minus 1. So it's ln 1 by x. Because this minus 1 goes inside and it becomes a power. You can understood this step. So if you're getting minus ln cos x for the last one, it's correct. That is only ln sin x. Sorry, ln sec x. Okay. Anyhow, so I'll take you through the step-by-step method for each of these. Let's discuss. So again, what you notice in this integral is that cos x is the derivative of sin x. And you have sin square x here. So it's very easy. Just substitute sin x as the dummy variable. So cos x into dx becomes dz. So substitute these two things. So the integral becomes z square dz, which is z cube by 3 plus c. So that becomes sin cube x by 3. Yes. That is the antiderivative. That's the first one. Like that, the second one was 2x into e raised power x square plus, remember what it was, 5 cube. Okay. So again, you notice that if you take this as gx, then g prime x, which is 2x, is present here. So that's what you do. You substitute x square plus 2 as your dummy variable. So 2x dx becomes dz. So now substitute both of these. So the integral becomes e raised power z dz. That's e raised power z plus c, and then please substitute. So that becomes your answer. So I'm just leaving these two for you to go through for a minute, and then we'll discuss the third, fourth. Third one is a little bit complicated. Okay, so let's come to the third and fourth one.
Sir, can you show the second solution?
Sorry, the second one?
Yes, sir.
Yeah, it's complete.
Okay, sir. You can scroll, sir.
Okay. You understood the steps now in the second one?
Yes, sir.
Okay. Now the third one, you have to understand here that this thing 1 plus sine square x, if you take that as your gx, then what is g prime x? Is the differentiation of 1 plus sine square x, which is 2 sine x cos x. This is something that you have to be able to identify. Otherwise, it becomes very difficult to do it. That the differentiation of sine square x by chain rule is 2 sine x into derivative of sine x, which is cos x, which is. So it should be obvious. Otherwise, this question becomes difficult to solve. Okay. So once you have that, then you take 1 plus sine square x in that denominator as z. So 2 sine x into cos x dx becomes dz. So your integral now becomes quite simple. It becomes dz divided by root z, which is 2 root z plus c. That becomes 2 times square root of 1 plus sine square x plus c. So finally, this is your answer. So this is the third one's solution. So very good, Arushi, your answer was correct. Okay. Now let's move on to the last one. So this we know is by direct formula ln sec x, but if we want to solve it by using substitution method, now you can see that if you substitute cos x as z, then dz by dx is how much? It's minus sin x. So when you cross multiply, sin x dx is actually minus of dz. So you have to substitute that extra minus sign. So our integral will become minus of dz divided by z. That is minus ln z plus c. So that is minus ln z was cos x plus c. Now that is nothing but ln of cos x to the power minus 1. So that is ln of sec x plus c. So in that, as I said, we are using this property that ln of e to the power n is n times ln e. So ln of 1 by e or ln of a to the power minus 1 is minus ln. So the reverse of that this property is going to be useful.
Sir, in both subparts, third and fourth, can you just tell me how did you establish a relation between gx and g prime x?
Yeah, the same thing. So if you have taken this as gx, okay, then your integral is g prime x, okay, upon square root of gx. Understood? No? This is the integral.
Yes.
So that should be I of gx. Now, what is the antiderivative of 1 by square root function? Your f is 1 upon square root. No? So, the antiderivative of that is 2 times square root. Okay, so this will be 2 times square root of gx plus c. So, 2 times square root of 1 plus 1. Like that, okay.
Okay, sir.
Now, similarly,
And the
here you
fourth
can
one.
see that. So, you have taken cos x as g. No? So, there's that extra minus sign upon gx. No? So, your f is actually 1 upon. F of gx is 1 upon. So, antiderivative is ln. So, I of gx will become ln of gx plus. So that's how it is ln of cos x. But there's the extra minus sign because of this. Okay. So that extra minus sign here will give you actually minus of ln cos x plus. Got it now?
Okay, sir. Yes, sir.
Okay. Now we'll do some examples of definite integration to wind up integration today. Okay. So we have discussed last time how to do a definite integration. So first of all, a definite integration has two values here, which are called the limits. So to calculate the value of the definite integration, we first solve the antiderivative, and on that antiderivative, we put the limits. So the value becomes antiderivative at upper limit minus value at antiderivative at lower limit. So for example, if we have integration of sin x from 0 to pi by 2, the antiderivative of sin x is minus cos x. So on that we have to put the limit 0 to pi by 2. So it will become minus cos pi by 2 plus c. C actually cancels out, so we need not write it also. Minus of minus cos 0. So cos pi by 2 is 0. Cos 0 is 1. So as you can see, you get 1. So the value of this integral, this definite integration of sin x from 0 to pi by 2, value comes out to be 1. And we had also seen the geometrical meaning of this. Okay, this is actually the area under the graph of y is equal to fx between x equal to a to x equal to b. So this represents so if, let's say this curve represents the function y equal to fx's graph, and this point is x equal to a, this point is x equal to b. So then this area between a and b subtended by the graph of the function y equal to fx, this area is exactly equal to the value of this integration, this definite integration. So in this particular example, the one that we are getting is actually the area subtended by the graph of y is equal to sin x. You can see that this point is pi by 2. This point is 0. So the area that we are talking about in this integral is this area. This area is basically integration of sin x from 0 to pi by 2, which is 1. So this is something that we are familiar with. So just as you're noting down this, you can try out a couple of examples. So when you compare these two, we'll get an interesting result here. Sometimes we write the limits with x equal to a and x equal to b also. It means the same thing. So let's try out these three questions. Make sure that we are clear with the application of definite integration.
So done.
Yeah. Send me the answers. What is the value of the first one, the area?
Half.
Yes, very good.
Minus
Vedant, that's,
half.
yeah. Arushi correct, Vedant correct. Second one,
Second one is 0.
Sir,
yeah, second one,
is minus.
that's correct. Arushi correct for the third one also. So the antiderivative is x minus x square by 2 plus c from 0 to 1. So the upper limit is 1 minus half. C anyway cancels out, so I will not write it. So it's half. Now this also has a significance which you can understand very easily, because if you plot this function as a graph, it's a straight line graph. The function is 1 minus x. So what kind of graph we'll get? Y is equal to 1 minus x is a straight line. So if you plot the graph of this straight line 1 minus x, you can see that it's having a slope of -1 and a y-intercept of 1. So this point will be 1. This point will be 1. This angle will be 45 and all that. Okay. So 0 to 1, actually we are talking about this area. So this area you can see is the area of a triangle which has height 1 and base 1. So it's that is what we are getting from here. Okay. But the second part, when we are doing the same thing, we are integrating, but the limit is going from 0 to 2. Now there's a reason why the answer you're getting is 0, because now you can see the second part, the area is this. Okay, so this area will actually be counted with a negative sign. It will be minus half. So that's why the total area from 0 to 2
Half plus half. Half minus.
is actually half minus half. That's why the answer is coming out to be 0 when you do it by the indefinite integration also. I mean by the definite integration. The upper limit is 2 minus 4 by 2. Lower limit is 0. So it's 0. So that's why you're getting this. Okay. Let me check how many of you got the third one. Arushi, your answer is correct. Anybody else has got the third one? Yes, correct, Vedant. Just a second, my whiteboard is shut off. I'll just bring it online again. So first of all, you have to solve that integration using substitution. So 0 to pi by 2, you wanted to calculate cos x into e raised power sin x integration. So when you're doing this integration, this indefinite integration, you can see that if you put sin x as z, then cos x dx becomes dz. So the integration becomes e raised power z dz, which is e raised power z plus c. So that is e raised power sin x plus. So this is your indefinite function. So you have to use this now. So here this will become e raised power sin x plus c. And on this antiderivative, now we'll put the limits from 0 to pi by 2. So upper limit you can see is becoming e raised power sin pi by 2. Okay. Lower limit is e raised power sin 0. So that is e raised power 1 minus e raised power 0, which is e minus 1, is approximately 1.7. So that is the value. Okay. So with this, we complete calculus. Now, make sure that you work out all the module exercises. So particularly exercise 2 and exercise 3 from module 1, basic calculus chapter. Try to work those out this week. Exercise 4, if you have begun, then very good. But if you have not yet started, first concentrate on 2 and 3. Exercise 4 is like the kinematics type applications. So we'll pick some of them up in the next chapter when we're doing kinematics also. But these two, complete them by next week. Okay, so that we can discuss the doubts in the next lecture also. Okay, we'll do the doubts, some of the questions and doubts on these two exercises in the next lecture, and we'll start with kinematics thereafter. Okay, kinematics will start from the basics, regardless of what has happened in the board lecture, because that is a separate thing. There's a separate thing. Okay, so don't worry about that. That's it for today's session, people. Wish you all the best. Thanks for
Thank
attending.
you, sir.
Thank you,
Thank
sir.
you,
Bye,
sir.
sir.
Thank you, sir.
Okay,
Bye,
Bye,
sir.
sir.
Bye, people. Bye.
Thank you so much.
Thank you, sir. Bye.
Thank you,
Okay,
sir.
bye.
Bye, sir.